It's time. The potential of data and AI is too big, and the problems we're solving are too important for it to be so hard. It's time to set your data up for success. Time to let it drive, because data is all grown up now, but we still haven't taken the training wheels off. It's time to be open, to unlock, unlimit, and unleash data. It's time to work together as data teams, as a data community. Innovation doesn't happen in isolation, because when we're united, we do what teams do best. Above all else, it's time to simplify. One place for all your data. One foundation for every workload, from BI to AI. One platform that runs where you run. One architecture that puts an end to the trade-offs and brings it all together. One Lakehouse. Databricks helps data teams innovate faster on the world's first and only Lakehouse in the cloud. Open, simple, collaborative. Now you can have it all your data, all your analytics and AI, all your data teams. One platform for today and in the future. It's time for Databricks.
Hi, everyone. Welcome to this session on Azure Databricks Essentials. My name is Hao, and I'm a partner solutions architect at Databricks based in Singapore. Very happy to be your host today for the next 1 hour, and we'll be looking at these two parts as agenda. In the first part of 30 minutes, we'll be looking at what a lakehouse is and how do we use Delta to build a lakehouse architecture. Then we'll take a look on an end-to-end machine learning on Azure Databricks. Then in the second part, we'll be looking at a lot of demos. First, we'll give a tour on Azure Databricks workspaces on the components. Then we'll be looking at an example of a streaming workload on Delta tables. Then we'll look at how to do an end-to-end machine learning model from training to registry and to serving. And in the end, we'll be looking at more on the BI side on how to use Power BI to connect to your SQL endpoint and then to do the query stuff, right? So without further ado, the first chapter. If we are saying Databricks only have one product, that will be Lakehouse. So Lakehouse is a next generation architecture that we're pushing everywhere. It combines the benefits of data lake as well as your traditional data warehouses together. And this will be one single platform to unify all your data, analytics, and AI workloads. The project or the tool behind it that we use to build Lakehouse is called Delta Lake. Delta Lake is also an open source project that helps you to implement the data management and governance layers. For example, by having a transaction layers on top of all your commits, as well as all the tracking capabilities there. So if we zoom out a bit to see what is today's modern data and analytics needs, we first start from the very bottom, like all the different types of data, structured, unstructured, big or small data, and fast or slow data in the big data world, right? So after we have put this into the raw layers in the raw data, we should do a curated layer on top of it. Then we'll be mounting our data applications like data engineering or streaming workload onto it. Or a step further, we can do data science and ML workloads on it. And then after we have some reports kind of table, we can directly query that and for our BI users, right? So for that vision to happen smoothly, you should have the right foundation from the very beginning. And our view is to have Delta Lake to help you to achieve this goal. So this foundation should have all these capabilities like handling data of different types and any size and coming at different speeds. And it should also be an open format and without any vendor locking problems. This should also widely support across major Azure data services, and it should provide management and governance capabilities and with ACID transactions and all the audit history to building. Then this platform should also be the single source of truth for all the data in your enterprise. So Azure Databricks is such a platform to build this hosting. It provides a simple architecture with proven patterns for all the data, and it maintains a open standards and without any vendor locking problems. It also provides you with a collaborative environment, such as all your data teams are breaking the silos between them and can work together seamlessly between your data engineers, data scientists, and BI users, data analysts, right? So also, if you see this block of Azure Databricks, it has a few components. The major ones are data engineering, machine learning, and data science. The third one will be for SQL analytics and BI workloads, right? So all of these are supported by the Delta engine. So what is the reason to choose Delta Lake to serve as such a platform, right? Quite a lot of reasons. Delta will be a tool that supports very well for your data engineering workload and real-time applications within this Lakehouse architecture. And it adds reliability as well as performance governance as well as quality to the existing data lake. It's also based on open data format. If you see the underlying data stored in your ADLS data lake, that's still going to be your Parquet file. It's just like using Delta brings additional committed file and with a transaction recorded as JSON or Parquet. Right? It's also the way to simplify the whole process to do data engineering with a curated data lake approach. Here we are proposing the medallion approach called bronze, silver, and gold layers. This pretty much means depending on the maturity of your data, you use your raw data and then put it into ingestion layer, that will be your bronze. Then after some cleaning, some filtering and augmentation, you have your silver delta tables. And in the end, after all kinds of data engineering or feature engineering tasks, you will have your gold layers ready to serve your downstream applications. So the medallion approach that we're pushing really simplifies the whole data processing pipeline. So the common limitations or the issues with data lakes in general are listed as below, right? If we categorize them into three, the first type will be during ingestion and ETL processing. If you are using Parquet-based tables, modifying existing data is actually very difficult. You will have to load the data back into some data frame to do manipulation and then to write it out somewhere else. Also, incremental processing is difficult, and not to say that streaming and real-time applications on Parquet-based tables are very difficult to see that. Second category will be on performance. So especially for a streaming job on Parquet-based tables, you often will encounter too many small files problem, and if there's no proper indexing on that, the performance of querying them will be very bad. The third type will be on reliability as well as data quality control. So in Parquet-based tables, there's basically no such things like data quality capabilities or data versioning or audit histories. But if you are using Delta, all of these problems have their solutions. Like in Delta, naturally, it provides ACID transaction support. You can do updates, you can do deletes or merge on your tables directly. Then it also have built-in capabilities to do CDC, and you also have Delta CDF change data feed capabilities for easier and smoother processing of your changed data. Using Delta tables, as later on we'll be seeing a demo, you'll be able to processing batch and streaming data simultaneously on the same table very easily. On performance sides, Delta actually provides you quite a lot of APIs to do optimization, like automatic file compaction and z-ordering and smart indexing, all kinds of stuff, right? On the data quality, you can have built-in data expectation on Delta tables. Then you also have all the audit history available for you. If we take a look on all the ingestion and ETL patterns in general, here's an important slide to do a summary, right? So on the very left, you have all sorts of data like structured, unstructured, or streaming data, batch data coming in. Depending on your existing workflow, you can choose different Azure services to do the ingestion. Like for streaming data, you can use Event Hubs. Uh, then for your batch data, you can actually use Data Factory to do the job, right? So in the middle, we'll be proposing Databricks to do all the ETL processing to build your curated layer into all the Delta tables, like your first coming into your bronze layer, then to your silver and gold layers. Then after you have built the lakehouse, that is like this block here, you can then mount different kind of applications onto these tables. No matter it's from like your silver table or gold table, you can directly consume from all of these curated layers. Like your data science project can get directly consume Delta tables, then your BI workloads can also consume from them as well. Your Power BI can directly query the Delta tables, or it can go through signups, right? So it's pretty much depending on your use case and usage of the scenario. So this is the proposed way, and also a proven architecture with Azure Databricks as a core component in your data processing pipeline and serving layer, right? So for data engineering and streaming with Databricks, this is really to simplify the whole process. For example, it has a built-in increment processing and CDC support. It's also providing you with single compute and storage layers. So the whole thing is really to make things simple and open and collaborative and provide such a platform for all your data teams. So how do we get started to build Lakehouse using Delta? It's actually very easy to start with. So if you are already using Parquet tables, that's even simpler. So you can just say like instead of using Parquet, you can just say using Delta. Then for write out, it's the same. You can just change Parquet to Delta. That's it. All right. So that's for the syntax wise. If you already have Parquet-based tables, it's also very easy to convert them into Delta tables. Just one line to say that convert to Delta and give your Parquet tables pass, right? Then after you have created the Delta table, you can do optimization and on the layout for faster queries later afterwards to do like optimize your table and the order by the columns, right? Delta also supports you to do like updates, upserts, operations. For example, you can use merge into in Spark SQL very easily to update the tables. Later on, we'll be looking at a detailed example how to use this, right? A very interesting capability Delta provides naturally is time travel capability. You can, since now you have different versions of your tables, you can actually travel between the versions. Like you can do select as a timestamp as of which timestamp or as of which versions, right? Um, so you can also do like rollback if you have accidental bad writes on the tables. So the next topic we're covering today is an end-to-end machine learning example on Azure Databricks. So just now we've covered how to do the ETL process to build all these bronze, silver, and gold layers of your Delta tables. Then if you are doing machine learning workloads, you'll be, for example, consuming them from Databricks, and you'll be using the managed ML flow to do all the model tracking and model registry and model lifecycle management. After that, you have already got a model artifacts, then you can do the serving layer. So you have a few options in the serving, including, for example, serving it by batch or as a streaming manner, or you can make this into a REST API to shoot your request towards that to get the inference value. Then on Azure, you can also deploy to other services like AML endpoints or like AKS to do the serving. of your model, right? So in Databricks, brief look on how like ML training at scale happens look like this, right? So first we provide the ML runtime. So it is a prepackaged environment for you that contains most popular ML toolkits in the market. It also simplifies the distributed machine learning or deep learning and provides you with very handy clusters to do the task, right? There's also built-in AutoML and auto logging for you for example, the first models or like benchmark models kind of workloads. So to use ML flow, it roughly looks like this, right? So data scientists will come in, choose their favorite framework to do the machine learning model, to create those models, and they will be packaged into these flavors in ML flow. And while a training process happens, MLflow will automatically track the things, track the model artifacts, track everything that you want happening in the process into the tracking server. Then after these artifacts are tracked, you can use MLflow model registry to register these models officially into MLflow model registry, right? And to manage the life cycle in the registry there. Then in the deployment option, you can then leverage Azure-based deployment, or you can serve the models within Databricks using a single node cluster like that, right? So Azure Databricks Machine Learning will be a data native and collaborative solution for the full ML lifecycle. It's built on top of open data lakehouse, as well as the Databricks feature store. So from the model training, model registry, serving, and governance, it's all integrated within a single platform. It's also supporting multiple languages within notebooks, so you're so to cover different flavors of the data scientists. There's also very tight collaboration between your data teams, like your data engineers, data scientists, and ML engineers. The notebooks in Databricks supports multiple languages like Scala, SQL, Python, and R. Then it has native support that multiple people can work in the same place. It also provides a very clear experiment tracking with managed ML flow integration. So the process, if we simplify, it looks like this, right? So we can do data ingestion, data preparation first, and then to create the features, register the feature tables, and then data scientists will come in to do the modeling parts. After the model is complete, it will come to the serving part and then goes back. And behind all the scenes, you can build your ML ops logics to do all the kind of automation stuff, things there, right? So ML ops, as we just mentioned, will actually equals to data ops plus DevOps plus ML ops. So each of these will be taken care of by our features in Databricks. So for example, data ops, Delta tables provides automatically data versioning as well as data quality control. You also have Databricks feature store ready to show you upstream and downstream lineage, like which data source this feature come from and what model is using this set of features. Then for the Databricks repos, it is a place to link up with your VCS version control systems, and then to do your code versioning and library management sort of things like that, right? Then for the model ops part, obviously we'll be using MLflow quite a lot to track all the experiment tracking or experimentation process, and then to manage the lifecycle of your models in model registry, and to make everything reproducible, right? So you can also distribute the model training very easily, for example, using Horrible Runner for common ML libraries, right? Then it also supports a lot of other flavors, like it supports native Spark integration, also like Spark ML and Pandas UDF, for example, right? So some relatively newer ML features include, first, you have smoothless you have very smooth integration for Koala's integration, and now you can use pretty much Pandas API to write your code. So if you are a Pandas lover, you can pretty much write your code in Pandas syntax, and the underlying is actually using Koala's data frame, Spark data frame to do the processing for you. In Databricks, you can also do one-click serving on your models. So once you have deployed your models, registered your models, you can now click this enable serving. So it spins up a single node cluster at the backend for you to do this kind of serving. So you can shoot your request to that endpoint. It will give you the predicted value like that, right? Databricks also have a relatively new feature called AutoML. So using AutoML, data scientists can very easily do a benchmark model without much effort in the beginning, right? So you can just apply a data set and specify the time that you want to train towards what target column. So this really simplifies the whole process and give you three things. First, it automatically creates a lot of MLflow experiments to try out different combinations of the algorithms. It also gives you data exploration notebooks, so you can do it. So it's more like automatic EDA done for you, and provides you with generated notebooks. It also provides you with reproducible trial notebooks. So it's actually generating automatically the code for you to do like further development on those scripts, right? So Databricks AutoML is actually using the glass box approach. You just need to do sort of configuration in the beginning, like choose your data set, choose what column you are predicting into, and whether this is like which type of prediction you want. And then you can just kick it off, and it will generate a lot of notebooks for you to, for example, choose your best models or to do like additional development on top of them. Then for the deployment, it's also very easy. As I've mentioned just now, you can do like one-click serving in Databricks on your models, right? Then in Databricks, there's also a dedicated place called Feature Store to register your features, right? So it's co-designed with Delta Lake and as well as MLflow. So when you have a Delta table as your source, you can actually create features on top of those and register those features into the feature store. And whenever you want to use them, you can just use fetch them from the feature store client. And Databricks Feature Store comes in two parts. One is the offline version, or like by batch, providing you with high throughput. And it also has another part called online part, right? So for the low latency feature serving for different purposes. And in Feature Store, it provides you with some lineage to link with upstream data source, like what data sources generated this feature, as well as downstream lineage, say what models or endpoints or like jobs is using this feature table, right? So all of this is to make it easier for people to navigate to see that where this feature is used and like how can I use this feature in my own project. Then you can actually have a dedicated Azure Databricks workspace to hold a centralized MLflow registry as well as centralized feature store. And you can have multiple workspaces linking to that. So it's more like sharing your MLflow registry and sharing your feature store across different workspaces. So this is important because you can use this capability to design your CI/CD pipeline. You can design your workflow and or to share things, share models between departments, right? If the departments are using different workspaces. So your experiments tracking can happen either like locally or for each workspace. So to summarize, Databricks machine learning provides all these key product features, and I'll just leave the keywords as there. It has links associated. So you can take a look later, right? Okay, so that pretty much is our first part content. Okay, so the first short demo we're looking at will be a tour on Workspace. So this is my Azure portal, and I'm in my resource group where I have a Databricks Workspace instance, right? I can just launch this Workspace. Yeah, to sign in. Yeah, so this brings me to the like front page of my workspace. So immediately, the first thing you need to know is there are three tabs in each workspace. The data science engineering, like if I click this, you will see all these ribbons. And machine learning, actually machine learning is on top of DS, all right? So it just gives you additional ribbons like that. And then Databricks SQL, right? If you click that, it brings you to the Databricks SQL page, where it's a little bit different, like it's using like SQL endpoints or sort of stuff, right? So let's go back to machine learning part. That's the main workspace, the main page that we're looking at today. So immediately you have your, for example, workspace tab. This is a place where you store all your notebooks. You can just create notebooks here, or you can import notebooks using like your local file by uploading from your local laptop or using a URL online, right? This can be pretty much anything like HTML file or like a GitHub file, right? So then you have repo. So repo is where you connect to your VCS system, like your GitHub. So where I'm connecting to my GitHub here. And then you have your data tab. This shows you like the database available to the current cluster, as well as like DBFS, for example, right? So then you have the compute tab, which shows all the kind of standard clusters in Databricks. So if you choose to create a new cluster, you can just say like test cluster. Cluster mode, you have like three modes: high concurrency, standards, and single node. Yeah, single node pretty much is just one VM at the backend, right? Then Databricks runtime is to choose different versions of images that will be run on your cluster. For example, here I'm choosing 9.1 long-term supported version, LTS. Then you can also choose ML versions, right? So if it comes with ML, it means it has quite a lot of prepackaged libraries installed for you, so you don't have to install your own. Then if you click this photon, only certain runtime will show up. And Photon is a new compute engine that's compatible with Spark, right? So if you choose this one, actually it will be much faster for the computation. Then you have your jobs tab. This jobs tab is more like after you have created your notebooks, you have run through them, and now you want to make it into production workloads, then you can pretty much create a job. And in the job, let's say you can run quite a lot of types of jobs here. Like for example, I'll choose notebook. Then you can choose your notebook here. Then you can choose your cluster as your compute resource, right? So another thing to note is that job cluster is also much cheaper than the interactive clusters. So we pretty much encourage workloads to go into production and use job clusters to save cost. Another thing to note on job cluster is that now you can actually reuse the job clusters. That's immediately saving you quite a lot of like expense here, right? Because you can, for example, if you have a lot of small jobs, you don't need to spin up multiple job clusters every time. Now you can actually reuse the job clusters across different tasks in the job here, right? So yeah, and then experiments is where, for example, if you run your ML flow experiments, it will be registered here. Right? Then feature store will be a dedicated place to store your feature tables. Models, this will be your model registry. So you can do a search here to see what models are available here, whether they are like in the serving mode or other things, right? So pretty much that's all of these tabs purpose here. And let's jump into the next topic. So next one will be looking at streaming workload. So on this notebook, the purpose is just to say, I have a bunch of JSON files coming into my ADLS location, and then I want to automatically ingest those like JSON files in the streaming manner into my Delta tables. So how do I do that? Right. So this is more like to show you the landing part of your raw streaming files into your Delta tables and to show the capabilities of Delta handling streaming workloads, right? So now I'm using a small clusters here to do this demo. I'm using my own storage account here, and I've specified the container name to be like that, right? So if I go back to this storage account and container, the thing I'll be doing is to use Databricks Autoloader. So this is a tool specifically to automatically ingest data, especially streaming data, into your landing table, right? I'll be using Autoloader to monitor this location of this container, and then to ingest all these JSON files into my Delta tables. So now I've already got like 2 files here. I'll add more. So because it keeps monitoring these locations, so it will automatically ingest. So that's the auto part of the autoloader, right? First of all, I'll need to create a few other containers as well for this demo to run. So I'll be creating like 3 sinks container, sink 1, 2, 3 for different scenarios. But just to remember that autoloader source container will be like where the source JSON file stores. Right? So first of all, you have to link your, you have to let your Spark to get authenticated to your like ADOS storage account, right? So here I'm using the ADOS access key here. So yeah, that is to get my Spark session to be able to talk, to read and write to that storage account. Then, for example, I have this widget here. This corresponds to the 2 boxes above here. And I can get these values from the widgets. So the very first scenario is how do we read in those JSON files from the source folder and to, for example, do some modification and write it out in a streaming manner into another location called sink1, right? So you can pretty much specify the source location. You just saw this one just now. And then the sink path. So sink will be using sink1, all right, as an output location. So it's as easy as like first specifying a schema that's from your like JSON file. Then actually autoloader can also handle like varying kind of schema. That's a property of like Delta, right? But here we're like for simplicity, we're using a fixed schema here. Then you can pretty much use spark.readstream, and to use autoloader, you can refer to the official docs, but the key point is you can just change the format to cloud files and specify all the properties that autoloader requires, right? So you can load this into a streaming data frame, and you can directly modify that data frame, for example, like create a new column here, and then to write it out like this one, right? Using like output mode as append. So if I do this, I have a streaming job, like initializing the streaming job here. So soon it will show me the process of doing this streaming job and see like how much records it's inputting and outputting, right? And processing, sorry. Yeah. So I can pretty much load the results back from the sync path. Then I can show the data frames content. Right. So you can see that now I have like 2 records coming in. Those are from the 2 JSON files that I've put in my container. So that's as easy as that for the simplest scenario. Second scenario is we can use the thing called for each batch, and you can supply a function to do such modification. This is important because most of the time, your modification won't be that easy. Like I can just do it on top of my data frame. Most of the time, you are going to need a function for that job, right? So similarly, we're going to use another sink, right? Sink2 as your output location. The source is the same. Now we're also going to see how to write out to different locations from the same streaming job. Same thing as before, specify your schema here, and then you can just create your streaming data frame coming in. Then I'm just using a very simple function like this. So note that because I'm actually writing out to multiple locations, so it's better that if you cache the data frame in the very first place, because you're using it multiple times, right? Then I'll do 2 transformations here. I can do all sorts of stuff in this function, like to create 2 additional data frames here, and then to write them out to different locations. In the end, I'll just unpersist to cache the data, right? Then I'll be writing, I'll be using this streaming in data frame to create the DF output, right? So these will automatically write to 2 places because I've specified it here. The logic is passed in as a function and using for each batch API here, right? Same as before, I have like the first processing of the 2 files, and then I have already written the content out to the 2 output locations as 2 records, right? So just now we've said, okay, let's refresh this one. So just now we've said autoloader job will actually keep monitoring all the files here, right, to see what have been processed, what has yet to be processed. So I can simulate a streaming event by, for example, adding in a bunch of new files into this container. So if I do that, and I go back to my streaming job, soon you'll see another spike here to show that the new records are being processed. And for all these streaming jobs, it will continuously to write out to the destination, right? So it should have finished processing. And then if I load them back, and indeed, I have much more records as before. That proves that I have successfully making this as an automatic chain to load the data into the underlying location as Delta format, right? So so just now we've seen, okay, we have been doing a lot of things in a file level, but we haven't registered those as tables, right? So to do it on the tables is also very easy. You just need to use merge into syntax, right? So for example, this is pretty much similar to just now, a function that tries to modify the existing data and is trying to see whether there's a match, and if there is a match, then update. When there's not a match, then just insert the unmatched records. So same thing as before, we can create this as a streaming job. Oh, by the way, and we're using the third output location called sync3 here. That's why in the very beginning, we created 3 syncs containers in the storage account, right? So yeah, now you've seen that this table should already contain quite a bunch of things, like 8 rows, for example. Yeah. And then I can try to add more here. Yeah, for example, I'll just add the 3 random files here. Oh, sorry, wrong tab. It should be here. Yeah. So in this streaming job, it will also see a spike soon, and then yeah, then we should be expecting the updated values in the ultimate table, right? Yeah, so it's processing, and wait for a few seconds. It should have finished. Yeah, so now we have like 9 records here, right? So indeed, we have seen the additional data being ingested into this table here. So that's pretty much it for the second demo. And now we can just use this to stop all the stream workloads here. Okay, so in the very next demo, we'll be looking at machine learning end-to-end example here, right? So the Databricks runtime I choose for my cluster here is DBR 9.1 LTS ML. And it's a 1+1 cluster, means 1 driver plus 1 worker, right? Oops. Yeah, so as before, I can use dbUtl widgets to create a variable called like demo simple model. Just by this one. And then I can get the value by using dbUtl and widget and .get model name here, right? So in Azure Databricks, we actually provide the managed version of MLflow, means that you don't have to specify your own tracking server. Databricks already have a tracking server up and running for you. So that is to track all the kind of experiments or the experimental runs in your experiment process, right? So, and then here I'm just like printing out the MLflow version. And to train a model, first we need to get the data sets. Now we're just downloading from online to get the wine quality CSV. And this will actually download. Oh, and this %sh is just to run all the shell commands here, right? In the driver of your smart cluster. So if you just do ls, you will see the CSV downloaded here in the driver's location. In the driver's local location. Then you can pretty much use copy to copy it to dbfs path. And just now skipped what dbfs is. dbfs is just the underlying workspace associated blob storage, right? So this storage account is for experimentations, is for like playing around with it, right? So for your production data, do not store on dbfs, but store it into ADLS, other storage account. Because when, for example, when this workspace is deleted, dbfs will also be deleted. It's a managed resource associated to your Databricks workspace. So I'll just do this, and then that copies my local file to the dbfs path, right? Then I'll just specify, say, the wine data path locates at the dbfs location. Then, for example, I can use pandas to read the files on dbfs. Yeah, it's just the very simple data sets from the wine quality example. And now we'll be using this data set to train a scikit-learn elastic net regression model. We'll be kicking off a MLflow run, but first we'll definitely create the MLflow experiment, and then to keep track of all the artifacts generated, like your models, like your sample data, all the things like that, right? Or everything that you want to be tracked in your experimentation process, you can pretty much define in the code snippet here, right? So we'll just be importing all the required libraries. And then this is pretty much a random kind of vector that I get from the CSV file. You can specify a particular input example when logging the model, right? The reason is that will simplify the serving part. When at serving later on, you will see it can automatically generate a sample data based on this input sample, and then you can send a request immediately to your endpoint. And then you can define something like a train model function, a convenient function. Here we're just doing like very standard steps like to do train test split. Then important thing is how to use MLflow here, right? You can pretty much trigger a MLflow training run by using this sentence called with MLflow.start_run. And here you will specify what algorithm you are going to choose, right? So here we're just choosing a elastic net model, and then just to use like lr.predict like that, right? And then the model metrics will be registered into the variables RMSE, MAE, and R2, right? So 3 metrics. Then you can use mlflow.log param to log the parameter, log metrics to log the metrics, log model to log the models. So if you find this to be like inconvenient, how do I know like what should I log? Then you can actually use MLflow autolog. That will log everything available coming out from this flavor of the model, which is ElasticNet, right? So we'll define our training function here. And just for demo purposes, we're specifying a like simple one combination of the parameter here, and then to run it. So if we trigger this one, we will trigger the train model process, right? And you can immediately say that one model is being logged into the experiment in MLflow. Then you can actually have a model URI. This is very important because here is where all your model's artifacts are saved, right? This is more like the path to that particular model you trained just now. So at this stage, if you go to the experiments tab, so from here, so because I've already run a few times of this one, so the latest run happens like 30 seconds ago, which is the one you just saw. So it's actually showing you all the things being tracked here, right? So from like it even have this input example and the model file itself and the requirements, right? So if we go back to here, the next step you can do is after you have trained your model, you can pretty much register the model into model registry. For example, if you can do this syntax and to register the model, you can see that I already have a model with the same name already existing on my model registry. So it's creating an additional version, like version 3 to it, right? Sorry, version 2 to it. So then if I go to my models tab, I'll be seeing that, oh, my demo symbol model now have a version 2 here. And it all have their own tags like staging or like no tags yet. So here you can go into each version and see what source run it had. So this will lead you to an MLflow experiment run result. So everything are linked here, as you can see. So very easily for you to track what happened and then to reproduce the run, right? And then programmatically, like everything you see here, like on the UI or the buttons clickable here, behind it, there's an API, right? So you can pretty much use MLflow client to do like transitions of the model version, model stage, like for example, model 2 to the staging, yeah, or like to the production like that, right? So just now what I did is to move model latest version, which is version 2, into staging, which is here, right? So now actually two models are both in staging, trained at different times. So the next thing I want to show here is in every, like for example, version of the model, you can actually, oh, sorry, yeah, oops, sorry, here. So in this version of the model, you can actually go to the serving part, right? So you can actually serve multiple versions of that model. Serving means you can use one-click solution to spin up a single node cluster, and this will be the cluster that can receive all your requests and then to do the evaluation. For example, because just now we've used we also logged the sample data here, so that's why by one click it shows me the example, and then I can do send request. It gives me the predictive result of the wine quality there. So that's as convenient as that to do like serving within the Databricks environment, right? Just as I said, everything that you see here have an API at the back end. So you can pretty much query the endpoint there programmatically as well, right? So yeah, so let me go back to the schedule here. That's pretty much it for the machine learning example from like just now you've seen how to do the model training, how to do the tracking in MLflow experiments, and in the end, register the models into Databricks model registry and turn on serving, and then to shoot a sample data towards that endpoint and to get a inference and to get the inference value back, right, as predicted value. So the very last topic we're talking about today is Databricks SQL. And for example, how do you use a Power BI connection to connect to that, right? Oops, right, just checking my Power BI VM. So that leads us to the third ribbon called Databricks SQL. So immediately you can see that the UI is a bit different here. So because this is totally dedicated for like SQL users. First, talk about the compute resources. Right. For example, I should have started this just now. So, for example, all the compute resources here are called SQL endpoint. You can pretty much choose, like, say, test SQL endpoint, and then the sizing is like you can see different price tag on that. That's Databricks unit price, from like very small to like very large, right? So to cater different use cases. Then you can turn on auto stopping and like scaling. Note that scaling in SQL endpoint is a little bit different because it scales by adding additional SQL endpoints cluster. So for example, if you have additional queries come in and it detects that, oh, I'll need more clusters to handle that, then it actually spins up an additional SQL endpoint to handle the concurrency for you, right? Advanced options, you can actually tag it and you can say, oh, whether I want a spot instance or like not, right? So yeah, here pretty much like scaling is very important to handle your or to tune to your workloads. In our example, we are using starter endpoint, which is a small size. Takes a while, right? So just show the yeah, sorry. I'll just show the UI here. So at the SQL tab, this is a dedicated place for like SQL users or like BI users, right? And then you can pretty much execute line by line here and in this editor. Yeah, so if I go back to Oh, so I need a SQL endpoint to be running first. Yeah, because I think just now it auto terminated after like 45 minutes of idle time. You can change the auto termination time, of course, right? So to a longer time. Then I'll just show you around. Like you can pretty much create queries and save the queries here. So like saving it as your SQL scripts. Then you also can create dashboard using like built-in Redash dashboards here. You can create dashboards. Uh, yeah, and in the dashboards you can add visualizations. Yeah, sorry, I haven't added any, but you can actually import sample dashboards. Like for example, I'll import the classic one. And again, it's pretty much dependent on first having a SQL endpoint available. But just on functional wise, you can actually add alerts. You can actually see the data in available to the SQL endpoints. And as admin, you can have quite a lot of handles on the SQL endpoints, right? You can see the query history. You can also analyze the performance, like durations of those queries, and yeah, and to do all the alerts stuff, right? Yeah, good. So I have a SQL endpoint up and running. Let me just go to my this one here. So I can go to my samples and then like that, right? So I can, oops. Yeah, so let's just run a sample demo here. So for example, yeah, I can just run my queries like that, right? So the very last thing that I want to show today is how do we connect to, how do we use Power BI Desktop to connect to SQL endpoint and leverage the computation power of the SQL endpoint there, right? So there's a tab called Partner Connect. Here, it includes a lot of partner solutions that provides like very easy integration here. It's still adding quite a lot more partner solution to that, but these are the available ones, right? So um, if you click this one, like Power BI connection, you can choose which SQL endpoint that you want to connect to. Let's say start endpoint. You can just download this file. So this pretty much is just hosting some JSON content like connection details, like where do you want to connect to. So if I go to uh, my Power BI VM, yeah, so because on the same laptop, yeah, I need the like Windows machine here. So this pretty much is the thing that I just downloaded, right? The Power BI connection config details. So yeah, it's also dependent on first you have a SQL endpoint and then it should be up and running. Then it will show me what are the available tables that I can connect to. Like for example, like sample, like this one, right? And then I can either choose to load the data set or like I can do like transformation on the data, right? So yeah, so that's how easy you can connect to SQL endpoint using Power BI, right? So and then you can pretty much do what you want in the Power BI here, right? Okay, so go back to our schedule. We've reached the end of today's topics. And just to summarize, in the first half of today's call, we've seen how to build Lakehouse architecture. What is Lakehouse architecture, and what benefit you can have by using Delta as an open source project to build your Delta tables. Then you've seen that how to use Databricks machine learning to build an end-to-end ML workflow. Then in the demo tour, you've seen like all the major components in Databricks workspaces, as well as how to do streaming workload to automatically ingest for example, JSON raw files into your Delta tables. You've also seen how to do end-to-end machine learning in Azure Databricks, right? At the very end, we've seen a little bit on the Power BI connection and what Databricks SQL is. So I hope you enjoyed today's session and see you next time. you.